Okay, in this problem, we have a block on the table connected to a string passing over a frictionless pulley to another block hanging off the table. And the assumption is that it's kind of slippery here on the table and that this whole thing could slide and fall down. But we have another block on top that's just going to give us some additional weight. And we want to know what is the minimum weight that we have to put on this block so that it doesn't fly off the table, but it stays there. So what you have to realize here is that we have this FW that's pulling the system down, and the only thing that could hold this on the table that has to counteract that force going down is going to be the friction that exists between the table and this collective set of blocks here. All right, so in the problem, they tell us the weight of these blocks. I found that a little bit confusing because I'm used to writing the masses of the blocks in the blocks, and I don't want to change my my method of doing things. So for that reason, block A has a weight, an FW of 44 newtons. So I'm going to divide by 9.8 so that I can write down the kilograms inside the block. So this block is 4.49 kilograms. This hanging down block has a weight of 23 newtons, so divide by 9.8. So this hanging down guy has a mass of 2.35 kilograms. So honestly, I just made the problem actually a little bit more complicated, but I think it's going to be an easier explanation. And then this is going to be block C, and I'm going to call this the mass of block C. And that's what we're trying to figure out, is what is the minimum mass of block C so that this collection of blocks here does remain on the table. If I want it to remain on the table, the frictional force here is going to have to equal the weight of that block that's hanging down. So that's kind of the concept that we're working with here. So let's put down the FW because that one's easy. That's the weight of the block that's hanging down, which we know is going to be 2.35 times 9.8, and we know that's going to turn out to be 35. Okay, so over here then we have to figure out what the friction is, which is going to be mu mg. So that is going to be mu. So it says that the coefficient of friction is 0.2. The mass is going to be the mass of the first block plus the mass of block C that we don't know what it is, times G, 9.8. So again, I think it just makes my math make a little bit more sense here. So I could cancel out those 9.8s, and then I could get 2.35 here. And I could multiply, I did not do this here, so 0.2 times 4.49, that's going to be 0.898 plus 0.2 the mass of block C. So 2.35 minus that, divide by 0.2, and I get the mass of block C turns out to be 7.24 kilograms. And if you wanted to know the weight, the FW of block C, we would just multiply that by 9.8 and find out that is 71 newtons. So if block C was 71 newtons and I stacked that on top of the other block, then I know that that's the minimum weight that would hold that system in place.